we want to solve a trig equation 2 cotangent x plus cosecant x equals 0 over the given interval. The first step is to perform substitutions using the reciprocal identities shown on the right, where cotangent x is equal to cosine x divided by sine x, and cosecant x is equal to 1 divided by sine x. Notice how the two fractions have a common denominator of sine x, and therefore we can add the two fractions, where the denominator is going to remain sine x, and the numerator is 2 cosine x plus 1. And this fraction is still equal to 0. The fraction is equal to 0 when the numerator is equal to 0 and the denominator is non-zero. And therefore the fraction on the left is equal to 0 when 2 cosine x plus 1 equals 0 and sine x doesn't equal 0. Remember, the denominator cannot equal 0 because division by 0 is undefined. We could have also multiplied both sides of the equation by sine x, and the result would be the same because of the 0 on the right side. And now solving 2 cosine x plus 1 equals 0 for cosine x, we subtract 1 on both sides and then divide by 2, which gives us cosine x equals negative 1/2. And now we need to find all the angles that have a cosine function value of negative 1/2 over the given interval. Let's do this using reference triangles and also verify using the unit circle. So ignoring the negative sign for a moment, having a cosine function value of 1/2 should remind us of a 60-degree angle or a 30, 60, 90 degree reference triangle where the cosine of 60 degrees, or 1/3 pi radians, is equal to the ratio of the adjacent sides of the hypotenuse, which is 1/2. But since we're looking for angles that have a cosine function value of negative 1/2, and cosine theta is equal to x divided by r on the coordinate plane, we will sketch a 60-degree reference angle and the corresponding reference triangle in the second and third quadrants where x is negative. If x is negative, then the cosine function value is also negative. So here's the 60-degree reference angle in the second quadrant and the corresponding reference triangle, where the short leg is negative 1, the hypotenuse is 2, and the long leg is square root 3. And now we'll sketch a 60-degree reference angle in the third quadrant, which would be approximately here. Where again the short leg is negative 1, the hypotenuse is 2, and the long leg is negative square root 3. Notice both of these reference angles do have a cosine function value of negative 1/2. And therefore the first angle over the interval from 0 to 2 pi radians that has a cosine function value of negative 1/2 is this angle here, which is 180 degrees minus 60 degrees, or 120 degrees. 120 degrees is equal to 2/3 pi radians. To convert from degrees to radians, we multiply by pi divided by 180 degrees. If we recognize that 1/3 pi radians is equal to 60 degrees, 120 degrees is equal to 2/3 pi radians. And now the angle in the third quadrant would be this angle here, which measures 180 degrees plus 60 degrees, which is 240 degrees, and 240 degrees is equal to 4/3 pi radians. So our solutions are x equals 2/3 pi radians, or x equals 4/3 pi radians. Neither of these angles have a sine function value of 0, and therefore these are the two solutions. But let's go ahead and verify this on the unit circle. Remember, on the unit circle, x is equal to cosine theta, which means we're looking for an x-coordinate of negative 1/2, which again will be in the second and third quadrant. So here we have an x-coordinate of negative 1/2, which means the cosine of 120 degrees, or 2/3 pi radians, is equal to negative 1/2. We also have an x-coordinate of negative 1/2 here in the third quadrant, where the angle is 4/3 pi radians, or 240 degrees. So this verifies our two solutions of x equals 2/3 pi radians as well as x equals 4/3 pi radians. I hope you found this helpful.